Hello, Pre-Algebra. We're going to be discussing a new way for proving the Pythagorean theorem. It starts, this is by Nadia. In it, you have to be able to do what's called a binomial, multiplying binomials. So it's not as hard as that sounds. So I'm going to show you a quick example of it over on this piece of paper. The question starts, what is the area of this rectangle? We got 12 times 7. 12 is the entire length all the way from this edge all the way out to this edge. 7 is the length from this edge to this edge. So the area of the square, we know, would have to equal, 84. But what we can do to make it simpler on ourselves is it might not be simpler right now, but this is going to be helpful when we talk about variables and stuff. So let's say we break 12 up into 10 and 2. And we break 7 up into 4 and 3. Notice that the length of this is still 12 and the length of this is still 7. But what we've done is we've broken it up into sections. What we've done is we've changed the problem from 12 times 7 into a problem that looks like 10 plus 2 times 4 plus 3. And that's going to be key. First, we're going to do 4 times 10. The area of this is 40. All right. Next, we are going to do the bottom one. 10 times 3. That is 30. Next, we will do this side over here. This is a 2. This is a 4. So the area of this would be 8. And finally, the area of this last box is 2 times 3, which is 6. This is called the area method for multiplication. I know they've been doing it recently. I don't know if this is something that you've learned when you were in 3rd, 4th grade. But this is very helpful for understanding binomials, which you don't need to understand what that means at all. Okay, when we add all this up together, we get that the area is equal to 40 plus 30 plus 8 plus 6. That's 14. That's 5 plus 3 is 8. And just a quick look on our calculator, just to make sure. 7 times 12 is indeed 84. So how does this help us? How does this help us at all? Well, we're first going to look at how can we get the answer of 40, 30, 8, and 6. These answers from this thing right here. Obviously, if you did 10 plus 2, you get 12. 4 plus 3, you get 7. And then you can do 12 times 7, which is 84. But it's going to be more beneficial if we talk about how we can get these 4 areas from this right here. So, in order to do this, we do what's called foiling. Foiling. We take the first numbers from each. First number from each. 10 times 4. 10 times 4 is equal to 40. Next, we are going to do the outer. That's the outside numbers. So this is the outside, and that's the outside. So we do 10 times 3. Times 3, which is 30. Next, we do the inner numbers. That would be the inside numbers here, which is 2 and the 4. We multiply those together. 2 times 4, and we get 8. And finally, we do the last numbers. The last number in each of these, that's a 2 and a 3. The last number of each of these, 2 times 3, is equal to 6. And when we add these all together, we get that the answer here is equal to 84. That's how we can multiply two things like this. You might think, what's the purpose of this? Well, the purpose lies in when we aren't dealing with strictly numbers, we're dealing with variables as well. Let me give you an example. This next one is going to be a little bit sloppier because I'm not using the ruler to help me out. Obviously, the size of these, I try to make it look nice and even, but it doesn't matter. This line could have been way over here if I still had this represent 10. This is just a visual aid for us. So, let's say that I wanted to multiply a plus 4 times a plus 1. Well, whatever the size of a is, I'll put that there. These are multiplied. And I'll put a 4 up here. Next, so that's my a plus 4. Next, this side will be my a plus 1. I'll have an a over here and a 1 over here. So keeping with my color scheme, as best as I can manage, get all my colors out. I want to multiply a plus 4 times a plus 1. So I'm going to FOIL. My first numbers are going to be in blue, and they are the first numbers here. That's this area right here. A times a is a squared. So my first numbers is a squared. Next, the outer numbers. That's a times the 1. That's represented in this box right here. A times 1. 1 times a is equal to a. Well, it's 1 times a, but I can write it there, but I don't need to write that 1 there. Next, my inner numbers are 4 and an a. That's represented in this box right here. 4 times a is 4a. And I forgot to write the 1a down here. And finally, my last numbers, the 4 and the 1, represented right down here, is simply 4. So, multiplying this times this gives me an answer of a squared plus a plus 4a plus 4. These are like terms. We can combine them because the variable here is a, not a squared. A squared is by itself. That's 5a plus 4. You are going to need to know how to multiply these things when we're discussing Nadia's proof, and more importantly, what did she do wrong with her proof? What she has here is adequate, and this does prove what she's trying to do does lead to a proof of a squared plus b squared is equal to c squared. However, there's a mistake in here. So I want you to try to figure out how is what she's talking about in this thing lead to the realization that a squared plus b squared is equal to c squared. As you can see, the area of the inside square, she says, is c squared. Is that true? Figure it out. The area of the four triangles is 1/2 a times b. 1/2 a times b, is that the formula for a triangle? And then she says times 4. Would that give you the area of 4 triangles? Did she simplify this correctly? Finally, she said that the area of the entire square is a plus b times a plus b, or a plus b squared. Does this equal that? There's a mistake somewhere in here. You need to figure it out, and then you need to use this to convince somebody that a squared plus b squared would equal c squared. All right, good luck.